Welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 10 from the October-November 2022 Cambridge 9709 syllabus. This is the Pure Mathematics Paper 1, Variant 3 from October-November 2022. Now this question here starts off here about circles, equations of circles. You've got this circle and you've got this straight line. The circle, they gave us the equation x squared plus y squared equals 2, and the straight line, they gave us the equation y equals 2x minus 1. They told us they intersect at the point A and B. The point D on the x-axis is such that AD is perpendicular to the x-axis. We've got to first of all find the coordinates of the point A. So basically, point A is one of the points where this line and this curve intersect. Now, if you want to find where the intersection is between two functions, we have to solve their equations simultaneously. So we have to solve the equation y equals 2x minus 1 and x squared plus y squared equals 2. We have to solve these two equations simultaneously. Now, the whole thing about a way of thinking of this, way of terminology that people use when they say we solve equations simultaneously by equating the two equations. I don't like using that particular terminology because in a question like this, it kind of breaks down. It doesn't make things easy. I like to think of the understanding of you can find where these two functions intersect, the point of intersection, by substituting one of the equations into the other. That's a far more comprehensive way of understanding and of carrying out such a question. It will help you to, not get confused. So what I'm going to do is I'm going to take the 2x minus 1, which is basically what y is equal to, and I'm going to replace this y here with 2x minus 1 because y is equal to 2x minus 1. So I'm substituting one of the equations into the other equation. Oh, what happened there? Sorry. I'm substituting one of the equations into the other equation. That's what I'm doing. So I have here x squared plus, instead of y, I'm going to put 2x minus 1 squared equals 2. So now I have an equation with just x in it. So if I expand, and simplify, I should be able to solve this to find the coordinates of A and B. So we want the coordinates of A in the end, which is going to be the one which has a positive x and y coordinate. So now, let's expand this. So you have x squared plus, if you expand this bracket, remember when you expand a square bracket, you square the first term, that's going to be 4x squared. Don't forget to square the number as well. Then you multiply these together and double the product. So minus 2x, don't forget the minus 2x doubled is plus 4, minus 4x, sorry. So negative 4x. And then when you square negative 1, you get positive 1. On this side, you've got, it says equals 2. If we simplify this, you're going to have 5x squared minus 4x, and 1 minus 2 is minus 1 equals 0. Okay, so now we have to solve this quadratic equation, and we're going to solve this by factorizing. Now, I like to use this way of factorizing. When you use something, you have to split the middle term. I like to split it in this way, a visual kind of way. So I write the x squared term on the top left and the constant term on the bottom right. Then I find the product of these two, and whatever they multiply together to give you will be the same as the product of these two. So I've got 5 times 1, 5x squared times minus 1, which is minus 5x squared. That's the product. And the sum has to be minus 4x. So we can see that we're going to have a minus 5x and a plus x. So you can put minus 5x here, for example, and plus x here. And then we can find the factors. For example, I can look at this column. I can say the common factor here is 5x. And I know 5x times 1x gives me 5x squared. 5x times minus 1 gives me minus 5x. And what goes here? Well, x times 1 gives me x. So I'm left with 5x plus 1 times x minus 1 equals 0. Let's just confirm. 5x squared minus 5x plus x, that's minus 4x and minus 1. So we have x equals minus 1/5 and x equals 1. So this must be the x coordinate of A, because as we can see from the diagram, it's where x is positive. And to find the y coordinate, we can use this. It's easier for us to use this. So we say when x equals 1, y is equal to 2 times 1 minus 1, which is also 1. So the coordinates of A are 1 and 1. Okay, so there's the answer to part A. Pretty simple question there, just solving these pair of equations simultaneously, but be careful not to say equate them. If you say equate them, then some people do some really weird things. If you really truly want to equate them, you have to make y the subject of this. You're going to end up with square roots, and then it's going to become complicated. So just think about substituting one equation into the other. You normally take the linear equation and substitute it into the other by you find what y is, or sometimes you find what x is. You can replace the y with what y equals. You can replace the x with what x equals. Using the y here is much easier, right? So there's the answer to this question. Part A. We also have a part B and C of this question, so we'll go on to part B. Now, part B is more to do with integration. All right, so in fact, I mean, normally I would have saved this as 2 separate videos, but I'll just carry on because that first question wasn't too lengthy. So I'll save this into 2 different playlists. One of them will be for basically solving equations, all right, and the other one will be for this topic, which is integration. Okay, this is to do with integration. It says, find the volume of revolution when the shaded region is rotated 360 degrees about the x-axis. Give you your answer in the form pi over a times b root c minus d, where a, b, c, and d are all integers. Okay, so what does that mean? Basically, what it means here is we have to take this little area and we have to rotate it around the x-axis the whole way around. So it's like it's going to come out of the page and go into the page all the way around, forming a 3-dimensional kind of shape. It's going to be kind of like a, part of a sphere, of course, right? So it's going to come out of the page, go back into the page. Okay, so what is this principle based upon? Well, if you have an area that you want to rotate around the x-axis, okay, it's going to form a 3-dimensional shape. And if you think about it, if you take a small little part of it, so small that it's like a little tiny rectangle, and you were to rotate that around, then that would be like a little cylinder in the end after it's rotated around. Okay, because if you rotate it all the way around, it'll form like a cylinder with a small thickness, and this would be the radius of the cylinder. This thickness would be like the height of the cylinder. And the volume of a cylinder is pi r squared h. So this small length h, we call it a little bit of x, tiny part of x. And this, the r is going to be the y coordinate of this point. Okay, that's going to be the r. So we can say that the volume of this is going to be pi times y squared times dx. Now, if we were to take the sum of all of the small cylinders, really tiny cylinders, from the start to the end of our object, and add them together, that will give me the volume of the whole cylinder. So if we find the sum of all of the pi y squared dx's between, say, this point A and B, okay, between A and B, that will give me the volume of the cylinder. So that's exactly what happens when we integrate. So if we integrate pi y squared dx, then it will give us the volume which is formed when this shaded region is, rotated around the x-axis between the points x equals a and x equals b. So how do we relate this to this question here? If you didn't quite understand that, it's not a big deal, okay? As long as you understand what I do next, okay? So the volume of a solid which is formed when a shaded region like this is rotated 360 degrees around the x-axis is found by finding the integral of pi y squared dx. This is like the radius, this is like the height of the tiny cylinders that would be formed. Okay, so pi y squared dx. I like to write the pi on the outside, but just don't forget it's there, that's all. Okay, and we got to do it between the limits of where the shaded region begins to where it ends. Okay, so now what do I know about this shaded region here? Okay, it begins at D. Now we know the coordinates of A was 1, 1, so the coordinates of D is 1, 0. So I know this point is 1. So if I'm going to make my limits, I'm going to take this area here. My limits are going to be between 1 and this point here, which is where the circle hits the x-axis. Now, this circle has a center 0, 0, and a radius is going to be the square root of 2, because remember we have x minus a squared plus y minus b squared equals r squared. So the center is the origin, okay, and the radius is root 2. So this point here is root 2. This point here is root 2. So between 1 and root 2 is the limits that we have to use. And we got to take y squared. Now, if we think about what y squared is, okay, we got x squared plus y squared equals 1. So y squared, equals 2. So y squared is equal to 2 minus x squared. So we got to take y squared, which is 2 minus x squared, and integrate that with respect to x. Okay, so it should be the integral of y squared with respect to x. Now that should give us the volume form. Don't forget the pi. Don't forget the pi. Okay, so that should give you the volume form. So you got pi times, I'm going to integrate, so I'll put this as square brackets. If you integrate 2 with respect to x, you get 2x. If you integrate minus x squared with respect to x, you're going to get minus x cubed over 3. And then we have our limits, root 2 and 1. We don't need to put plus c because the c will cancel out anyway when you subtract these, when you put these values in. So the volume is going to be given by pi times, now I'm going to have 2 times root 2, so 2 root 2, minus, this is also going to be 2 root 2 because you've got to have root 2 cubed, which is like root 2 times root 2 times root 2, 2 root 2. So this is minus 2 root 2 over 3, minus, and then I'll put 1 into here. So we're going to have 2 times 1, which is 2, minus a third. Okay, so that should give us our answer. So you have pi times, so 2 root 2 minus 2 root 3, 2 root 3 over 3. That's like you could say divided by 3, that's 6 root 2, 6 root 2 over 3 minus 2 root 2 over 3. That's going to give you 4 root 3 over 3 minus, and you're going to have 2 minus a third. 2 minus 1/3 is going to be 1 2/3. Okay, or you can say 6 over 3 minus 5 over 3. So you end up with, in this form, pi over a, b root c minus d. So pi over a. So you can see there's a 3 common. So pi over 3 times 4 root 3 minus 5. This is units cubed. Okay, pi over 3 times 4 root 3 minus 5. So it looks right. We have those integers in those places that we want to. So it looks like we've done the right thing. So we found the volume of revolution of this as we rotate it around the x-axis 360 degrees. And for part C, it says find an exact expression for the perimeter of the shaded region. An exact expression for the perimeter of the shaded region. So we got this over here and this over here. So let me just get this diagram and sort that out. I'll just copy this diagram as it was before I did anything to it. Paste it over here so we've got some space to look at it. Okay, so now we want to find an expression for the perimeter of the shaded region. Now, the perimeter of the shaded region is made up of the following lines. Change the color so we can see it. You've got this line over here, and you've got this line over here. Okay, those are 2 of the lines. And you've got basically this, which is the arc of this circle. So we need to find, well, this is the coordinates 1, 1. So A to D, so you got AD plus, let me call this point E, plus DE plus the length of the arc between A and E. So we know that AD is equal to 1 because the y coordinate of A is 1. Okay, we got this. Now, DE is the length of this line. Okay, now this, remember, this is root 2, this is 1. So DE is going to be root 2 minus 1. Root 2 minus 1 will be this length over here. Okay, that's why it says exact expression, because you want to keep there's going to be root 2 in it. And then we have the length of the arc between A and D. So we've got to consider this. So there's another topic coming into this question, which is to do with radian measure, arc lengths. Okay, so we need to know, well, we know this is 1, so this is 45 degrees. So this is 45 degrees. Now, if we're going to use radian measure, so I'll use this as pi. So pi over 4. So this is pi over 4. Why? Because this is 1, 1. That means 45 degrees, which is pi over 4. So we can say the length of the arc AE is given by the formula. We know the length of the arc is given by r theta. So the radius of this circle, okay, the radius of this circle is root 2, as we know. So it's going to be, r is going to be root 2 times theta, which is pi over 4. So it's root 2 times pi over 4. So therefore, we can say the perimeter of the sector is 1 plus root 2 minus 1 plus root 2 pi over 4. So the 1's cancel out. You're left with root 2 plus root 2 pi over 4. So that's the perimeter of this shape. Okay, it's that number of units. An exact expression means don't use pi as a decimal, don't use root 2 as a decimal, leave it in surd form. And there is the answer. And that completes this question number 10 from the October-November 2022 paper from Cambridge 9709. Other questions from this particular paper can be found in the playlist that will appear in this section over here. Other questions dealing with solving quadratic equations, simultaneous equations. I'll put that in this, playlist over here. You can find other questions dealing with, or this, the playlist dealing with integration, okay, volumes of revolution and integration in the playlist over here. And what was the last thing we did? We did radian measure as well. So I'll put a playlist there for radian measure. So there's lots of different topics in this question, actually. And yeah, so that's basically this question. There will be a card appearing during the video, which takes you to the playlist for this paper, where other questions that I may have answered from this paper will be collected in that playlist. Okay, thank you for watching and see you soon.